Good morning, boys and girls. Okay, now today we'll see the types of motion. Okay, so there are four types of motion: translatory, rotatory, oscillatory, and vibratory. Okay, first one is translatory motion. So, this is the definition. A translatory motion is a motion in which all the parts of a body move through the same distance in the same interval of time. That means the whole body is moving and not there is no partial movement. Okay. Now this translatory motion is also of two types. So rectilinear and curvilinear. So rectilinear motion. This is a motion uh, which is in a straight line. Okay. So a body or object when moves in a straight line, that is called rectilinear motion. For example, a bird moving in sky, you can see, or uh, you you play some games like carom or golf or okay, so many examples are there. Or you when a batsman hits a ball, that also the ball moves in a straight line. Okay, so these are some example. No, actually, the ball when moves along the ground, then only it's a straight line. Okay, now curvilinear. When a movement of object moves in a curve, that is curvilinear. By the name itself, it is very clear. When you throw a stone at an angle in the sky, so when it follows a curved path, okay, so it's a curvilinear motion. Or when a basketball player throws a ball, or in cricket also when you hit a ball high, then it moves in a curve. Okay, so or javelin throw, you must have seen in during sports time in our school also, javelin throw, it goes up and then it comes down in a curve. Okay, so these are the examples of curvilinear motion. Now the next one is rotatory motion. Okay, so it's very clear by the name itself. Rotatory means rotation. What do you mean by rotation? When an object is moving around the same fixed axis, okay, without changing its position. Okay, its position is the same, but it's rotating at its fixed axis, like electric fan or all the motors, in fact. Okay, all the motors revolve around the same axis. Then the potter's wheel, if you have seen a potter's wheel, okay, this is how a potter makes pots, by moving a fixed wheel and putting clay over here and then giving the shape by his hand. Or the top, okay, spinning top, if you have played with a top, then when it spins at a fixed it spins on the ground, so it spins around its axis, which is its nail, that is the axis. Around it revolves, that rotates. Okay, not revolves, it rotates. Okay. Okay, then next one is oscillatory motion. Oscillatory motion is the back and forth motion in which takes place about a mean position. Okay, there is a mean position. Mean position is always when the object is at rest. So that position is called its mean position. Like a pendulum, when it's rests, that is the mean position, and when you pull it and release it, it starts moving. Okay, and that motion is called oscillatory motion. It always passes from its mean position uh, back and forth. Okay, so a pendulum or a swing, if you swing freely, that means once you apply force, then you remain quiet, then it swings in a oscillatory motion. Okay, it follows back and forth movement, and that is oscillatory. Okay, then next one is vibratory. Okay, now vibratory motion. So when strings of musical instruments, strings or the what you say, uh, okay, strings, when guitar, someone is playing guitar, then strings are vibrating, and that's how the sound is produced in this guitar. And also in tabla or the other musical instruments. Okay, the what do you say, there is vibratory motion, that's how vibration is produced. Okay, the okay the okay, so all the, in fact all the mm, uh, musical instruments and other also you can see where vibration is produced. Where, let me see, in a tongue, in physics lab, or you can okay, then come to the next topic, periodic motion. Periodic means when a motion is for a fixed movement, it moves uh, the fixed distance along this fixed path, then it is called periodic motion. Now here oscillatory motion is also periodic. Okay, because here also time is fixed. For one oscillation the time remains the same in pendulum. Okay, so or the this. Okay, so now uh, periodic is also when like the earth revolves around the sun in a fixed period of time, that is 365 days. Okay, 365.25 actually. Okay, same way the sun revolves around our earth in this 37.3 days. Or you can see other examples. Oscillatory also here is periodic also, periodic only, because it has fixed interval of time for fixed motion. Okay, one oscillation is always of the same time. Okay, these are the types of motion. Now simple pendulum will come to next one is simple pendulum. Okay, so an ideal simple pendulum is heavy point mass suspended by a weightless, inextensible and a perfectly flexible string from a rigid support. Okay, now what is a pendulum? When a heavy point mass should be heavy, not very light, that means not of a cotton or paper, but it should be a heavy mass. Okay, suspended by a weightless string, flexible, okay, which can bend and which cannot expand also, not like rubber band it expands. So like that there should be string from a rigid support. That means support also should not move, it should be uh, strong enough and fixed and uh, retain its size and shape. Okay, so that's how, if you tie that heavy weight, uh, heavy mass through that string to a rigid support, then that is called a pendulum. Okay, in physics lab you can see, or practical, there is a brass ball, small brass ball, which is suspended by a string. Okay, you can take thread like you use for your kites, that thread can be taken and you can fix on your ceiling somewhere. Okay, some support or from wall you can take some support, some, okay, rod or something you can fix there and tie it there. Now when the bob is displaced from its mean position, then begins to oscillate. Okay, when you take the bob to one side and uh, release it, then the bob starts, that is called bob, the weight, it start oscillating, okay, to and fro from its mean position, and the motion is regular and repeating, and uh, its time is fixed. Okay, that's why pendulum is used in clocks and watches, because its time period is fixed. Okay, now there are some non-periodic motions. Non-periodic means when a motion is not taking the same time for same distance for same time. Okay, when it repeats itself at non-regular intervals of time. So when motion is repeating but the time is different for uh, okay, the repetition, that is non-periodic. Like the motion of a car driving several blocks on a busy downtown street. Actually, when you drive any vehicle, uh, it has different speeds at different levels. Okay, different time. When you have okay, your road is free from other vehicles, then you can drive fast, and when it's busy you have to slow down. So there is not a, it's not a periodic motion, or it's a non-periodic motion. Or motion of your dog you can take, or motion of fingers when you type. So these are some examples of non-periodic motion. Now there can be combination of motions also. Okay, so combination of two types of motion, or maybe three also can be there. So okay, now about this next topic. Okay, up to here we'll do. Okay, because it will be too much for today. So next topic we'll take in the next class. Okay, up to here you read it thoroughly. Okay, you just from here, uh, types of motion, go through it at least twice. You should read and find some examples yourself other than which are given in book. Okay, find some other examples for yourself. So it's very interesting if you find this, and that will make it very clear to you. And then we'll move to the next topic in the next class. Okay, and also at least once you go through the next page. Okay, this page at least, and this topic, complete this topic. So up to here, okay, the motion up to uniform and non-uniform also we'll discuss in the next video or the next class. So from distance up to here we'll do, then we'll cover it in the, because it is something different now, the distance, speed and other things will come. So at least read up to here, this to okay, and we'll take it in the next class. Okay then.